HAZWOPER Hazardous Waste Operations and Emergency Response Training Course. Table of Contents. Introduction to HAZWOPER. Regulations and Standards. OSHA, EPA, DOT. Hazard Recognition and Classification. Personal Protective Equipment, PPE. Site Safety Planning and Hazard Assessment. Decontamination Procedures. Emergency Response and Spill Containment. Toxicology and Health Effects of Hazardous Materials. Respiratory Protection and Air Monitoring. Confined Space Entry and Safety. Handling and Disposal of Hazardous Waste. Incident Command System, ICS, and Emergency Response Planning, Case Studies and Practical Applications, Final Assessment and Certification. Why take this course? Hazardous waste operations and emergency responses are among the most dangerous activities in any industrial setting. Exposure to toxic chemicals, biological agents, and radiological materials can cause serious injury, illness, or death. This course equips workers and emergency responders with the skills and legal understanding needed to handle hazardous materials safely and respond effectively in emergencies. HAZWOPER training is legally required under OSHA Regulation 29 CFR 1910.12 for anyone involved in hazardous waste cleanup or emergency response. Completing this course ensures both compliance and confidence in high-risk environments. Who needs this course? This course is essential for workers and organizations involved in hazardous waste site cleanup and remediation, emergency response to chemical or toxic spills, waste, storage, transportation, and treatment facilities, environmental health and safety, EHS teams, chemical manufacturing, oil and gas, and utilities, disaster response, fire services, and civil defense, supervisors and safety officers in hazardous operations, regulatory compliance teams. Learning outcomes. By the end of this course, participants will be able to 1. Define HAZWOPER regulations and explain their legal foundation. 2. Identify chemical, biological, radiological, and physical hazards. 3. Understand the classification systems, NFPA, GHS, DOT. 4. Select and use appropriate personal protective equipment, PPE. 5. Follow donning and doffing procedures to avoid contamination. 6. Develop and implement a Site Safety and Health Plan, SSHP. 7. Recognize contamination zones, hot, warm, cold, and control movement. 8. Perform decontamination and disposal procedures safely. 9. Respond to hazardous material spills and coordinate emergency containment. 10. Explain toxicology basics, exposure routes, and health effects. 11. Apply lessons from real-world case studies and simulation exercises. Course modules. 1. Introduction to HAZWOPER. History, Purpose, Regulatory Framework, OSHA 29, CFR 1910.12. 2. Hazard Recognition and Classification. Chemical, biological, physical, ergonomic, and radiological hazards. NFPA, GHS, and DOT classification systems. 3. Personal Protective Equipment, PPE. PPE levels, AD, selection, maintenance, and limitations. Donning and doffing procedures. 4. Site Safety Planning and Hazard Assessment. Developing a Site Safety and Health Plan, SSHP. Defining work zones and control procedures. 5. Decontamination procedures. Physical, chemical, and biological decontamination. PPE cleaning, disposal, and contamination control. 6. Emergency response and spill containment. Spill response stages, containment methods, booms, dikes, and absorbents. Cleanup and proper disposal methods. 7. Toxicology and health effects. Exposure routes, acute versus chronic effects, and medical surveillance. 8. Case studies and practical applications. Deepwater Horizon, Fukushima, tabletop drills, confined space rescue. Introduction to HAZWOPER. Definition and purpose. HAZWOPER, Hazardous Waste Operations and Emergency Response, is a set of regulatory guidelines developed by OSHA Occupational Safety and Health Administration under 29 CFR 1910.12. The purpose of HAZWOPER is to protect workers involved in hazardous waste cleanup, treatment, storage, and emergency response to hazardous substance releases. It establishes safety protocols, training requirements, and response procedures to minimize risks associated with hazardous materials. History and development. HAZWOPER originated from the Superfund Amendments and Reauthorization Act of 1986, which aimed to address hazardous waste site cleanup. The regulation was developed to prevent worker exposure to harmful substances and ensure proper safety measures. It was influenced by several industrial disasters, including Love Canal disaster, a toxic waste dump site in New York that led to health crises. Bhopal gas tragedy, 1984, a chemical leak in India causing thousands of deaths. Chernobyl nuclear disaster, 1986, highlighted the importance of emergency response in hazardous environments. OSHA officially introduced HAZWOPER in 1990 to create structured guidelines for hazardous waste operations and emergency responses. Importance in workplace safety. HAZWOPER training is critical in ensuring that workers handling hazardous substances are well prepared to identify and classify hazardous materials, prevent and respond to chemical spills and releases, use personal protective equipment, effectively minimize exposure risks to hazardous chemicals, follow proper decontamination procedures. Industries that benefit from HAZWOPER training include manufacturing, waste management, chemical production, emergency response teams, and construction companies handling hazardous waste. Key roles and responsibilities. HAZWOPER regulations define different roles within hazardous waste operations, including site workers, perform hazardous waste cleanup and disposal under safety guidelines. Supervisors and managers oversee compliance, training, and safety implementation. Emergency responders handle hazardous material spills and emergency situations. Health and safety officers conduct risk assessments and ensure workplace safety measures. Incident commanders coordinate emergency response efforts under the Incident Command System, ICS. Each role requires specific levels of HAZWOPER training, ranging from 24-hour basic training to 40-hour advanced training for high-risk operations. Quiz. What is the primary purpose of HAZWOPER? To train construction workers on building codes, to ensure safety during hazardous waste operations, to regulate environmental recycling practices, to increase workplace productivity. Hazard recognition and classification. Types of hazardous materials. Hazardous materials can be classified into different categories based on their physical, chemical, and biological properties. The primary types include chemical hazards, includes toxic substances, corrosives, flammable liquids, oxidizers, and reactive chemicals. Examples: acids, sulfuric acid, hydrochloric acid, flammable solvents, gasoline, acetone, oxidizers, hydrogen peroxide, ammonium nitrate. Biological hazards involves microorganisms, toxins, and biological agents that can cause infections, diseases, or allergic reactions. Examples: biological hazards involves microorganisms, toxins, and biological agents that can cause infections, diseases, or allergic reactions. Examples: bacteria, anthrax, salmonella, viruses, hepatitis B, influenza, fungi, and mold aspergillus, black mold, bacteria, anthrax, salmonella, viruses hepatitis B, influenza, fungi, and mold aspergillus, black mold. Radiological hazards. Materials that emit ionizing radiation which can cause cancer or radiation sickness. Examples: uranium, plutonium, medical radioactive isotopes, cobalt-60, cesium-137. Physical hazards. Materials that pose risks due to their physical properties, such as explosiveness, reactivity, or extreme temperatures. Examples: compressed gases, propane, oxygen tanks, cryogenic liquids, liquid nitrogen, reactive metals, sodium, magnesium. Ergonomic and mechanical hazards. Although not always classified as hazardous materials, improper handling of chemicals or unsafe workplace conditions can cause injuries. Examples: heavy lifting of hazardous waste containers, equipment with pinch points or sharp edges. Hazardous material classification systems. Different organizations have developed classification systems to identify and communicate hazards associated with materials. The three main classification systems include NFPA, National Fire Protection Association, NFPA 704 Diamond. O uses a color-coded system with 4 quadrants to indicate hazards. Blue health hazard, 0 no hazard, to 4 deadly. Red flammability hazard, 0 will not burn, to 4 very flammable. Yellow reactivity hazard, 0 stable, to 4 explosive. White special information. Symbols for specific hazards. For example, OX for oxidizers, acid for acids. GHS, globally harmonized system. Standardized worldwide labeling system adopted by OSHA. Uses pictograms to indicate hazards, including flame, flammable, pyrophoric, self-heating, health hazard carcinogens, respiratory issues. Includes signal words, danger, or warning, and hazard statements on labels. DOT, Department of Transportation. Hazardous material classes. Regulates the transportation of hazardous materials using placards with specific hazard classes. Class 1, explosives. Class 2, gases, flammable, non-flammable, toxic. Class 3, flammable liquids. Class 4, flammable solids. Class 5, oxidizers and organic peroxides. Class 6, toxic and infectious substances. Class 7, radioactive materials. Class 8, corrosives. Class 9, miscellaneous dangerous goods. These classification systems help workers quickly recognize and respond to hazardous materials. Identifying physical and chemical hazards. To safely handle hazardous materials, workers must identify both physical and chemical hazards. Physical hazards: flammability, easily ignites and burns. Explosiveness, capable of violent reactions. Reactivity, unstable and may release toxic gases. Corrosiveness, can damage metals, skin, or tissues. Compressed gases, stored under pressure and may explode if ruptured. Chemical hazards. Toxicity, harmful when inhaled, ingested, or absorbed through skin. Carcinogenicity, can cause cancer over time. Mutagenicity, may cause genetic mutations. Sensitization, can trigger allergic reactions. Acidity divided by alkalinity, extremely high or low pH can cause burns or irritation. Proper hazard identification ensures that workers use appropriate personal protective equipment, PPE, and emergency response procedures when handling hazardous materials. Key takeaways. Hazardous materials include chemical, biological, radiological, physical, and ergonomic hazards. The NFPA, GHS, and DOT classification systems help categorize and communicate hazards. Identifying physical and chemical hazards prevents workplace accidents. Labeling and safety data sheets, SDS, provide essential information for safe handling. Quiz. What does the GHS pictogram of a flame indicate? Explosives, flammable materials, radiation, environmental damage. Quiz. What color in the NFPA diamond indicates health hazards? Red, blue, yellow, white. Personal protective equipment, PPE. Personal protective equipment is essential in hazardous waste operations and emergency response to minimize exposure to harmful substances. Proper selection, use, and maintenance of PPE can significantly reduce health and safety risks. PPE levels: A, B, C, D, and their applications. PPE is categorized into 4 levels: A, B, C, and D, based on the degree of protection needed for specific hazards. Level A, maximum protection. Highest level of protection for respiratory, skin, and eyes. Application, when the highest level of respiratory and skin protection is required. Unknown chemical exposure or extremely toxic environments. Oxygen-deficient atmospheres or exposure to highly hazardous chemicals. Includes fully encapsulated chemical-resistant suit, self-contained breathing apparatus, SCBA, chemical-resistant gloves, inner and outer, chemical-resistant boots, two-way communication system. Limitations: heat stress risk due to full encapsulation, limited mobility and visibility. Short air supply, SCBA, limits duration of use. Level B, high protection. Same respiratory protection as Level A, lower skin protection. Application: high respiratory protection needed, but skin contact hazards are lower. Situations with airborne contaminants not absorbed through skin. Emergency response to unknown spills. Includes SCBA, or supplied air respirator. Chemical-resistant clothing, but not fully encapsulating. Chemical-resistant gloves and boots. Hard hat if required. Limitations: does not fully protect against skin-absorbed chemicals. Prost. Less thermal protection compared to Level A. Level C. Moderate protection. Lower respiratory protection. Similar skin protection as Level B. Application. Airborne contaminant concentration is known at when air purifying respirators, APRs, or powered air purifying respirators are sufficient PPRs, non-immediate, life-threatening, hazardous environments. Includes air purifying respirator or powered air purifying respirator, PAPRP, chemical-resistant gloves, boots, and clothing, hard hat if required. Limitations. Cannot be used in oxygen-deficient environments, not for unknown toxic environments. Level D. Minimal protection. Basic work clothing and protection for nuisance contaminants. Application. No significant respiratory or skin hazards. Work environments where minimal exposure to hazardous materials is expected. Routine cleanup and monitoring work. Includes safety glasses or face shield, work gloves as needed, coveralls or standard work clothes, boots divided by shoes, steel toe if required. Limitations. No respiratory protection. No chemical-resistant materials. Not suitable for handling toxic substances. Proper selection, use, and limitations of PPE. Selecting the correct PPE depends on work conditions, chemical exposure, and the level of hazard. Key factors to consider. Identify the hazard. Determine if the exposure is chemical, biological, radiological, or physical. Evaluate exposure risks. Consider airborne contaminants, skin contact risks, and toxic effects. Choose appropriate PPE. Match the PPE level to the specific hazard. Ensure proper fit. PPE should be comfortable and provide a secure seal for respirators. Understand PPE limitations. No PPE offers 100% protection. Proper procedures must be followed. 3 things you should know about PPE. AEG Environmental. Example: a chlorine gas leak requires Level B. SCBA. Chemical-resistant clothing. Handling low-risk cleaning chemicals may require only Level D. Gloves, safety glasses. PPE maintenance, inspection, and storage. Proper care of PPE ensures effectiveness and durability. 1. Inspection. Before and after use. Check for tears, punctures, or degradation in suits and gloves. Inspect respirators for damaged seals, valves, and filters. Verify SCBA air tanks are full and properly functioning. 2. Cleaning and decontamination. Wash chemical suits with approved cleaning agents. Clean respirator face pieces and filters as per manufacturer guidelines. Dispose of contaminated PPE. Properly hazardous waste protocol. HSE Study Guide. Storage guidelines. Store PPE in clean, dry areas away from direct sunlight. Hang chemical suits to prevent creasing and damage. Keep respirators in sealed bags or designated storage to prevent contamination. Common issues from poor maintenance. Damaged PPE reduces protection and increases risk. Poor storage leads to PPE deterioration. Improper cleaning spreads contamination instead of preventing it. Donning and doffing procedures. Wearing and removing PPE. Proper donning, putting on and doffing, removing PPE ensures safety and prevents contamination. 1. Donning PPE before entering hazardous area. Step 1. Inspect PPE for any damage before wearing. Step 2. Put on inner gloves if required. Step 3. Wear protective clothing, coveralls, suits, or chemical-resistant gear. Step 4. Put on boots. Cover pant legs inside boots. Step 5. Wear respirator or SCBA, ensuring a tight seal. Step 6. Wear outer gloves over the sleeves to prevent exposure. Step 7. Use tape to secure gloves and suit openings, if required. Step 8. Conduct a final check with a partner. Buddy system. 2. Doffing PPE. Removing PPE to prevent contamination. Step 1. Remove outer gloves. First, pull them inside out. Step 2. Unzip and remove the suit carefully, turning it inside out while stepping out. Step 3. Remove boots without touching the exterior. Step 4. Remove respirator last to avoid breathing contaminants. Step 5. Wash hands and exposed skin thoroughly. Step 6. Dispose of or decontaminate used PPE properly. Common mistakes in PPE removal: touching contaminated surfaces during removal, removing respirators too early, exposing oneself to airborne hazards, skipping hand washing, leading to secondary contamination. Key takeaways. PPE is categorized into 4 levels, A, B, C, D, based on exposure risk. Proper selection and fit of PPE is critical for protection. Regular maintenance, inspection, and storage prevent PPE failure. Following correct donning and doffing procedures reduces contamination risks. Quiz. What is a major limitation of Level D PPE? It's too heavy for extended use. It provides no respiratory protection. It causes skin irritation. It can only be used in nuclear facilities. Quiz. What should be done before donning PPE? Begin the task immediately. Eat a heavy meal. Inspect all equipment for damage. Skip glove usage. Site safety planning and hazard assessment. Site safety planning and hazard assessment are critical components of hazardous waste operations and emergency response. Proper safety planning helps to identify, evaluate, and mitigate risks to protect workers and the environment. Developing a Site Safety and Health Plan. SSHP. A Site Safety and Health Plan, SSHP, is a structured document that outlines hazard control measures, emergency response protocols, and worker safety requirements. It is required by OSHA's HAZWOPER standard, 29 CFR 1910.12 for hazardous waste operations. Key components of an SSHP. 1. Site description and project scopio identifies the location, operations, and hazards present. Describes the nature of work being conducted. 2. Personnel roles and responsibility. SO defines responsibilities for site supervisors, safety officers, and workers. Establishes chain of command and communication protocols. 3. Hazard identification and control. Measure. SO lists known and potential chemical, biological, physical, and radiological hazards. Outlines protective measures, including PPE and engineering controls. Site-specific safety plans. 1. Personal protective equipment. PPE. Requirements. SO specifies the appropriate PPE levels, A, B, C, or D, for different work areas. Includes proper donning, doffing, maintenance, and storage procedures. 2. Work zones and site control measure. SO divides the site into exclusion zone, hot zone, high-risk contamination area, contamination reduction zone, warm zone, decontamination area, support zone, cold zone, safe area for administration and logistics. 3. Decontamination procedure. SO specifies procedures to prevent the spread of contaminants. O lists require decontamination stations and equipment. One, Emergency Response Plano establishes protocols for fire, chemical spills, medical emergencies, and evacuation. Includes contact information for emergency responders and regulatory agencies. 2. Medical Surveillance Programo requires pre-employment and periodic medical exams for workers. Monitors workers' health exposure levels and symptoms. 3. Training and Safety Drill requires workers to complete HAZWOPER training and refresher courses. Conducts regular safety drills and emergency response simulations. In quiz, what is the purpose of the Site Safety and Health Plan, SSHP? To provide insurance for workers, to define hazard control and emergency procedures, to train office personnel, to monitor stock prices. Quiz. Which zone is considered the highest contamination area? Cold zone, warm zone, exclusion zone, hot zone, green zone. Decontamination procedures. Decontamination prevents hazardous substances from spreading to workers, equipment, and the environment. It ensures compliance with OSHA HAZWOPER 29 CFR 1910.12 and minimizes health risks. Key decontamination steps. Decontamination stations. Set up in designated zones. Hot zone. Contaminated area. Warm zone. Decontamination area. Cold zone. Safe area. Equipment used. Decon showers, absorbent pads, neutralizing agents, scrub brushes, disposal containers. Decontamination methods. Physical. Rinsing. Scrubbing. HEPA vacuuming. Chemical. Neutralization. Oxidation. Solvent washing. Biological. Disinfectants. Autoclaving. Enzymatic cleaners. PPE and equipment decontamination. Disposable PPE. Proper disposal. Reusable PPE. Cleaning, disinfection, and inspection. Tools and equipment. Wiped down, pressure washed, or discarded if porous. Quiz. What is a key part of decontaminating reusable PPE? Tossing it into regular trasher. Burning it. Cleaning and disinfecting it properly. Giving it to another worker. Quiz. Where is decontamination typically performed? Hot zone, warm zone, cold zone, safe room. Emergency response and spill containment. One. Types of hazardous material spills. Chemical spills. Acids, solvents, toxic gases, biological spills, infectious agents, biohazards, radiological spills, radioactive substances, oil and petroleum spills, fuel, lubricants, industrial oils. Two. Spill containment methods and procedures. Immediate response. Alert personnel, evacuate if necessary, and secure the area. Source control. Stop leaks by sealing containers or shutting valves. Containment zones. Prevent spread using barriers and containment strategies. Three. Use of absorbents, dikes, and booms. Absorbents, pads, powders, and granules for minor spills. Dikes. barriers that redirect or contain liquid spills. Booms, floating barriers used for waterborne spills. 4. Cleanup and disposal strategies. Neutralization, chemical treatment for hazardous spills. Vacuum systems, used for large-scale spill removal. Proper disposal. Follow EPA and OSHA regulations for hazardous waste removal. Quiz. What is the first step in responding to a hazardous material spill? Clean up immediately. Evacuate the area. Alert personnel and secure the area. Dispose of chemicals. Quiz. Which tool is used to contain spills on water surfaces? Absorbent pad, vacuum, boom, Toxicology and health effects of hazardous materials. Understanding how hazardous materials affect human health is crucial for worker safety and regulatory compliance. 1. Routes of exposure. Hazardous substances enter the body through inhalation, breathing in toxic gases, vapors, or dust. Absorption, skin or eye contact with chemicals. Ingestion, accidental swallowing of contaminants. Injection, punctures or cuts allowing toxins into the bloodstream. 2. Acute versus chronic health effects. Acute effects, immediate symptoms. For example, burns, dizziness, nausea. Chronic effects, long-term illnesses. For example, cancer, organ damage, respiratory diseases. Lined list, a diagram of a scale. 3. Common toxic substances and their effects. Asbestos and silica. Lung diseases. Cancer. Benzene and lead. Blood disorders. Neurological damage. Pesticides and solvents. Skin irritation. Nervous system effects. Four. First aid and medical surveillance. Immediate response, eye washing, fresh air, emergency showers, medical surveillance, regular health monitoring for workers exposed to hazardous substances, OSHA and NIOSH guidelines, set exposure limits and medical checkup requirements. Quiz. What is not a common route of exposure? Inhalation, injection, vision, ingestion. Quiz. What is a characteristic of chronic exposure? Happens suddenly, occurs over a long period of time, always fatal, causes immediate burns. Case studies and practical applications. Applying real-world examples and hands-on training enhances HAZWOPER preparedness and ensures effective response to hazardous materials. 1. Real-world hazardous material incidents. Bhopal gas tragedy. 1,984. Toxic gas leak from a pesticide plant, causing thousands of deaths. Deepwater Horizon oil spill, 2010. Environmental disaster due to an offshore drilling rig explosion. Fukushima nuclear disaster, 2011. Radiation release after an earthquake and tsunami. Lessons from these incidents. Importance of early hazard detection. Need for proper containment measures. Essential role of emergency preparedness. Two, lessons learned and best practices. Use of PPE and proper decontamination prevent long-term health issues. Spill containment and cleanup efficiency. Minimize environmental damage. Incident Command System (ICS). Ensure coordinated emergency response. Three, tabletop exercises and drills. Mock spill response. Teams practice containment and cleanup. Confined space rescue drills. Safe extraction of workers. Chemical exposure scenarios. Quick decision-making under pressure. Basic bending process. 4. Practical demonstrations and role-playing. Hospital evacuation plan course. PPE. Donning and doffing. Proper use of protective gear. Decontamination line setup. Step-by-step cleansing of contaminated individuals. Emergency communication simulations. Effective reporting. And teamwork in crisis situations. Quiz. What is the purpose of tabletop exercises in HAZWOPER training? File paperwork. Simulate hazardous scenarios for response training. Write emergency manuals. Prepare meeting agendas. Quiz. Which drill involves rescuing workers from limited space? Oil spill drill, fire drill, confined space rescue drill, equipment training. Assessment and certification.